Okay, here is section 1.4, exercise 55. And here we're looking at removable, where are discontinuities and then whether they're removable or not. And so we have the function f of x equals tangent of pi x over 4, and this is piecewise defined, so this is the absolute value of x is less than 1, and x if the absolute value of x is greater than or equal to 1. So actually we have, this looks like a piecewise defined function with two pieces, but actually it's a piecewise defined function with three pieces because of these absolute values on the x. So, if we're looking at the number line here, there's -1, there's 1, and so this top part is in there, but the bottom part is actually here and there. And so generally speaking, x is a fine function, and tangent of pi over 4 times x, now that I know tends to have discontinuities. When I take the tangent of pi over 2 or 3 pi over 2 or minus pi over 2 and so forth, I know that the tangent is discontinuous. All right, so tangent of pi over 2 is undefined, and so I know that I'll get like a pi over 2 up here when x is equal to 2. So notice that tangent is well defined. Tangent of pi over 4x is fine inside here. Okay, so the tangent function itself, I don't have to worry about its discontinuities. And x, I certainly don't need to worry about its discontinuities. So if I'm going to have any, they're going to be right here at -1 and 1. And so, let's look at what happens at x equal -1. At x equal -1, I'll have f of -1 is equal to -1 because of x right there. Not the so it's not the absolute value of x. It's just if the absolute value of x is greater than or equal to 1, which -1, that's true, I get x. So I get -1. Now, though, what's the limit as x goes to -1 from the right? Okay, so I'm in there. Excuse me. And of tangent pi x over 4. Well, I can just do that by direct substitution. That's tangent of minus pi over 4. And tangent of minus pi over 4 is equal to, tangent of pi over 4 is 1. Okay, that's 45 degrees, and so minus pi over 4, that's going to be -1. Okay, so we get -1 there. Those are the same, and so since this limit, I know the limit coming from the right, definitely the limit as x goes to -1 from, the left here of x is also -1. So the limits match and the function is defined there. And so f is continuous at negative 1. How about at x equal 1? Well, same sort of thing. We have f of 1 is equal to 1 because it was just x. And we check that limit as x goes to 1 from the left this time. Again, you can come back and see, all right, we'd be coming in here from the left of tangent of pi x over 4. Well, again, I can do that by direct substitution. I get the tangent of pi over 4, but that's just 1. And so once again, the limit exists, and so the limit exists, the function exists, and so it's continuous. And so actually here we have f of x is continuous for all real numbers. So it's a piecewise defined function, but it happens to be a continuous piecewise defined function. Again, if we're going to have problems, we decided it could only be at these two spots, the negative 1 and 1. We could have had problems with this tangent, but the tangent was well defined inside the interval it's used, and so that was all good. So then we check those, and the function definitely existed, right? If I put in either negative 1 or 1, I just get out negative 1 or 1. So the function existed. So then the only other thing we needed to check was that the limit did exist, and so we checked that limit. Definitely, again, you know, the limit was fine coming in on this x side. So as we came in this way to the negative 1, that was fine because it was just x. Everything was good there. The question was, well, what if we come in, you know, this direction? Will that tangent function up here still give us a negative 1? And it did. And similarly, as we came into 1, it was okay. And so f of x is continuous for all real numbers.